Hey there, fellow cloud explorers. You know we always love a good deep dive, and you sent over a ton of info on Amazon EKS. And let me tell you, it's not just hype. We're
Yeah,
talking about harnessing the power of Kubernetes right on AWS. So
absolutely.
that means taking your containerized apps to a whole new level.
It really does. And we're diving deep into all this material.
Yeah.
Think guides, tutorials, the works
Yeah.
to extract the absolute essentials for you,
Right.
whether you're prepping for a big project or just curious about this whole cloud native revolution.
Yeah.
We're going to cut through the noise and help you grasp those core concepts.
Okay, so let's start with the big picture. Why is Kubernetes such a game changer? What's all the fuss about?
Well, Kubernetes was born out of the need to solve some pretty major challenges developers face, keeping mission-critical applications up and running 24/7 no matter what. And not just running, but scaling smoothly as demand fluctuates.
Right.
Imagine your app suddenly gets featured on a popular tech blog, and the traffic explodes. Kubernetes can automatically spin up additional resources to handle that surge without breaking a sweat.
So it's kind of like having an invisible hand that orchestrates all the moving parts of your application, ensuring everything runs smoothly, even in the face of unexpected events.
That's a great way to put it. And a key part of that orchestration is this concept of availability. Kubernetes is constantly monitoring the health of your application. If a server decides to take an unscheduled break, Kubernetes automatically relocates your workloads to a healthy server,
Oh, wow.
ensuring your app stays online and users don't even notice a blip.
Yeah,
Pretty impressive, right?
that's a huge relief, especially for those of us who've dealt with those late-night server emergencies. It's like having built-in insurance against downtime.
Mm-hmm.
But I've heard the term containers thrown around a lot in the context of Kubernetes. What exactly are they, and why are they such a big deal?
Think of containers as lightweight packages that encapsulate everything your application needs to run. The code library's dependencies all neatly bundled together.
Okay.
It's like shipping your app in a self-contained unit ready to run anywhere that supports Kubernetes.
Ah, that explains the portability and consistency everyone's raving about. So Kubernetes doesn't care if these containerized apps are running on my laptop in a data center or on AWS, as long as there's a Kubernetes environment ready to go.
Precisely. But Kubernetes does more than just manage where things run. It also makes sure they run well. One of the key concepts that makes this possible is that Kubernetes is declarative.
Okay.
You define the desired state of your application, and Kubernetes makes it happen,
So
like
now-
setting your app on autopilot to maintain its ideal configuration.
So I don't have to micromanage every little detail of my app's infrastructure. I can just tell Kubernetes what I want, and it figures out the how.
Exactly. Now let's dive into how this actually works in Amazon EKS. The core building blocks are clusters, workloads, and nodes. Imagine a cluster as a virtual data center where your apps reside.
Okay, so the cluster is like the foundation of my Kubernetes-powered world. But what about workloads and nodes? Where did they fit in?
Think of workloads as the heart of your applications. They're the containers that hold your code and dependencies. We'll get into the specifics of pods, deployments, and services a bit later. These are the key players in how your apps actually function within EKS.
Sounds like we're going down the rabbit hole of Kubernetes terminology. But I'm game. Now, what about nodes? Are those the physical servers that everything runs on?
Not quite physical servers, but you're close. Nodes are like the worker bees. They're the EC2 instances in the AWS world that run those workload containers.
Okay.
And EKS gives you options for managing them. We have EKS Auto Mode, which takes care of a lot of the heavy lifting for you. And then we have Managed Node Groups, which give you a bit more control over the specifics.
Okay, so it's like choosing my level of automation. Do I want to be hands-on with managing my nodes, or do I want to let EKS handle the details? Tell me more about this EKS Auto Mode. It sounds pretty intriguing.
Imagine having a dedicated team handling all the behind-the-scenes infrastructure tasks for your cluster. That's EKS Auto Mode. It automates things like compute autoscaling. That means dynamically adjusting the number of nodes based on the demands of your application. No more manual scaling headaches for you.
So if my app traffic suddenly spikes, EKS Auto Mode just spins up more nodes to handle the load, and then scales back down when things quiet down.
Exactly. And it doesn't stop there. EKS Auto Mode also manages networking load balancing DNS. All those complex configurations that can make your head spin.
Yeah.
It's like having a built-in expert taking care of all the nitty-gritty details, letting you focus on the big picture of your application.
Wow, EKS Auto Mode sounds like a dream come true for anyone who wants to streamline their operations.
Yeah.
And minimize the time spent messing with infrastructure.
Mm-hmm.
But what if I'm a bit more of a control freak and I want to have a say in how my nodes are set up? Is that where managed node groups come in?
You hit the nail on the head. Managed node groups strike a balance between automation and customization. You get to define specific configurations for your nodes, like instance types, security settings, updates, things like that. But AWS still handles the underlying management of those nodes, taking care of tasks like provisioning, patching, and scaling.
Okay, so with managed node groups, I can be as picky as I want about my nodes, and AWS will make it happen. That sounds like a pretty good compromise. But let's not forget about networking, the unsung hero of any cloud infrastructure. How does EKS handle making sure everything is connected and talking to each other properly?
Great point. Amazon EKS seamlessly integrates with your existing AWS network using the VPC CNI plugin. It's like having a dedicated network engineer ensuring that your Kubernetes clusters play nicely with your existing AWS infrastructure.
Okay.
And there are various ways to manage networking add-ons within EKS, so you have flexibility in how you handle traffic routing and DNS resolution.
It's reassuring to know. Now, speaking of seamless connections, what about connecting my EKS applications to other AWS services? I'm imagining a labyrinth of security hoops to jump through.
Not at all. EKS has a clever solution called EKS Pod Identity, and it's all about simplifying how your EKS applications access those other AWS services. Think of it as giving your app a secure passport to travel freely within the AWS ecosystem.
Interesting. So I don't have to wrestle with complex credential management within my application. EKS Pod Identity takes care of that for me behind the scenes.
Exactly. EKS Pod Identity takes on the responsibility of assigning and managing the necessary credentials, minimizing security risks, and simplifying the entire process.
Okay.
It's a win-win for security and convenience.
Security and simplicity, those are two of my favorite words. But we can't forget about performance. We want our EKS clusters to be lean, mean application running machines, right?
Absolutely. And that brings us to an interesting topic, Bottle Rocket. It's a purpose-built operating system specifically designed for running containerized applications. Imagine an OS that's laser-focused on security and efficiency, providing a streamlined environment for your EKS nodes.
Okay, so Bottle Rocket is kind of like a stripped-down, high-performance sports car compared to a bulky SUV operating system. It's all about speed and agility for my EKS nodes.
That's a fantastic analogy. Bottle Rocket is all about shedding the unnecessary baggage that comes with a general-purpose operating system, minimizing the attack surface and optimizing performance for your EKS workloads.
That sounds like a great way to get the most bang for my buck when it comes to EKS performance. But what about folks who might have some existing infrastructure, maybe some on-premises servers they want to integrate with their EKS setup? Can EKS handle that kind of hybrid scenario?
You bet. Amazon EKS is all about flexibility, and it offers some really powerful capabilities for those hybrid scenarios. We have features like AWS IAM roles anywhere, which extends the power of AWS IAM to your on-premises environments, and hybrid nodes, which allow you to seamlessly blend your on-premises infrastructure with your EKS clusters.
So you can get the best of both worlds. The scalability and flexibility of the cloud seamlessly integrated with your existing on-premises setup.
Precisely. It gives you the freedom to choose the best deployment model for your applications. Whether it's fully cloud-native hybrid or even edge deployments, EKS can handle it all.
Well, it definitely sounds like EKS is packed with features and capabilities. But before we get too lost in all the possibilities, let's talk about the bottom line. What's the cost of entry for this Kubernetes wonderland?
Good question. Amazon EKS, like many AWS services, follows a pay-as-you-go pricing model. You pay for the resources you actually consume. The EC2 instances that power your nodes, storage volumes, network traffic. The EKS control plane itself has a per-cluster hourly charge.
So it's all about transparency and flexibility. You only pay for what you use, which makes sense. Now, we talked about EKS auto mode and managed node groups earlier. Could you elaborate on how to choose the right compute type for my EKS cluster?
Absolutely. When deciding between EKS auto mode and managed node groups, it boils down to your desired level of control and automation. EKS auto mode, as we discussed, is the hands-off approach, where AWS manages the cluster infrastructure for you. It's perfect for teams that prioritize simplicity and want to focus on developing their applications rather than getting bogged down in infrastructure management.
So if I want to streamline operations and minimize the time spent tinkering with cluster configurations, EKS auto mode is the way to go.
Exactly. But if you need more granular control over your nodes and want the ability to fine-tune specific settings, then managed node groups are your best bet.
Okay, so managed node groups give me the reins to customize my nodes. But AWS still takes care of the underlying management tasks like patching and scaling.
Precisely. It's about finding the right balance between flexibility and automation. With managed node groups, you can define things like instance types, operating systems, security groups, and you can even use launch templates for even more customization.
Launch templates. Those sound interesting. Are they like blueprints for my EKS nodes?
You got it. Launch templates are essentially pre-configured recipes for your EC2 instances, which in this case act as your EKS nodes. They let you define a wide range of settings from instance types and storage options to networking configurations and user data scripts.
So instead of manually configuring each node from scratch, I can use a launch template to create a standardized configuration that gets applied consistently across my entire node group. That sounds like a great way to save time and avoid errors.
It certainly simplifies the process and ensures consistency across your EKS infrastructure. And another great thing about launch templates is that they allow you to incorporate custom AMIs, which are pre-built operating system images that can be tailored to your specific requirements.
Custom AMIs. So I could bake in my preferred software packages, configurations, and security settings directly into the operating system image itself.
Exactly. And when it comes to operating systems, you have a few options for your EKS nodes. Amazon Linux is a popular choice as it's a familiar and robust Linux distribution that's well suited for cloud workloads. But for those seeking a more streamlined and secure option, there's BottleRocket, which we discussed earlier.
Right, BottleRocket, the minimalist speed demon. It's all about maximizing performance and security by stripping away all the unnecessary fluff.
Right. That's a great way to put it. BottleRocket is designed from the ground up for running containerized applications, with a minimal footprint and a laser focus on security.
What sounds like BottleRocket is a game changer for anyone serious about squeezing every ounce of performance out of their EKS clusters. But what about the other big player in the operating system world, Windows? Can I run Windows-based applications on EKS?
Absolutely. Amazon EKS fully supports running Windows containers, so you can seamlessly integrate your Windows-based applications into your Kubernetes environment. It's all about providing flexibility and choice for our users.
That's fantastic. But I imagine there are some specific considerations when it comes to setting up and managing Windows nodes in an EKS cluster. It can't be as simple as just spinning up any old Windows server and calling it a day, right?
You're right, there are a few things to keep in mind. You'll need to use Amazon EKS optimized Windows AMIs, which are pre-built Windows Server images specifically designed for use with EKS. And you'll want to pay attention to things like networking configurations, security settings, and the choice of container runtime for your Windows containers. But don't worry, AWS provides comprehensive documentation and tools to guide you through the process.
So there's a bit more to it, but it's still manageable with the right guidance. Now, what about managed node groups? Do they play a role in managing Windows nodes in EKS?
Absolutely. Managed node groups are the preferred way to handle Windows nodes in EKS. They simplify the management and scaling of your Windows-based EKS workloads, taking care of much of the heavy lifting for you.
Okay, so managed node groups are the go-to solution for Windows nodes as well. They handle the underlying infrastructure management, letting me focus on deploying and managing my Windows applications.
Exactly. They streamline the whole process and provide a consistent and reliable platform for running your Windows containers on EKS.
That's great news. It sounds like EKS really does cover all the bases, offering a flexible and robust platform for running a wide variety of containerized applications, whether they're based on Linux or Windows.
It truly does, and it doesn't stop there. EKS also provides a rich ecosystem of add-ons and integrations that extend its capabilities even further. We'll delve into some of these later. Exploring features like the AWS Load Balancer controller, which makes managing load balancers for your EKS applications incredibly easy.
Load balancers, networking operating systems. It feels like we're just scratching the surface of what EKS can do.
You're absolutely right. There's a lot more to uncover, and we're just getting started.
Well, I'm eager to dive deeper into these topics. Let's explore some of the advanced features and integrations that EKS has to offer.
You know, with all the excitement around containerized applications and orchestrating them with Kubernetes, it's easy to get caught up in the technical details. But let's shift gears for a moment and talk about something equally crucial: security.
That's a great point. It's easy to get swept up in the cool factor of new technologies. But security should always be front and center, especially in the cloud, where our applications are exposed to a wider attack surface. So how does Amazon EKS approach this crucial aspect?
EKS takes a multi-layered approach to security, starting with the very foundation, the infrastructure itself. Remember those nodes we talked about earlier, the EC2 instances running your workloads?
Yeah.
Well, those instances can be fortified with security groups and network access control lists. It's like building a virtual wall around your EKS cluster, allowing only authorized traffic to enter.
So it's all about creating a secure perimeter around my EKS cluster. ensuring that only the good guys can get in. Makes sense. But what about controlling access within the cluster itself? How do I make sure that only authorized users and applications can interact with my Kubernetes resources?
That's where AWS Identity and Access Management, or IAM, comes into play. IAM is like the gatekeeper of the AWS ecosystem, allowing you to define granular access control policies for virtually every AWS service, including EKS.
Ah, IAM. It's all about granting the right permissions to the right entities. So how does this translate to the world of EKS?
With IAM, you can create fine-grained access control policies that determine who can perform specific actions within your EKS cluster. For example, you can control who can create, modify, or delete Kubernetes deployments, pod services, and other resources. It's all about ensuring that only authorized personnel have the keys to the kingdom.
Okay, so I can use IAM to define roles and permissions just like I do for other AWS services. That makes sense. But what about security within the applications themselves? I'm thinking specifically about those pods running my containerized applications. How do we ensure that those pods are secure and protected from unauthorized access?
That's where EKS Pod Identity comes in. It provides a clever and secure way for your pods to access other AWS services without having to embed sensitive credentials directly into your application code.
Right, we touched on EKS Pod Identity earlier. It's like giving my pods a secure passport to travel within the AWS ecosystem. But refresh my memory, how does it actually work?
It's actually quite elegant. EKS Pod Identity allows you to associate an IAM role with a Kubernetes service account. Now, any pod that's configured to use that service account automatically inherits the permissions granted to that IAM role.
Ah, I see. It's a chain of trust. The pod trusts the service account. The service account trusts the IAM role. And IAM, being the ultimate authority, determines what the pod can and cannot access. Pretty slick.
It is, and it significantly reduces the security risks associated with managing credentials within your applications. You don't have to worry about embedding AWS access keys and secret keys directly into your pod configurations, which is a big no-no from a security perspective.
Makes perfect sense. So we've got our cluster perimeter secured, and we're controlling access to Kubernetes resources and AWS services using IAM and EKS Pod Identity. What other security measures should we consider when deploying applications on EKS?
Well, remember those container images we talked about earlier? The ones that package up your applications and all their dependencies. It's crucial to ensure that those images themselves are built securely and free from vulnerabilities. Think of it like making sure the foundation of your house is strong and stable.
Okay, so it's not enough to just have a secure environment. We need to make sure the applications running within that environment are also secure. But how do we go about doing that?
It starts with choosing trusted base images. When you build a container image, you typically start with a base image, which is essentially a pre-built operating system template. You want to make sure you're getting these base images from reputable sources and that they're regularly patched and updated to address any known security vulnerabilities.
So it's like choosing a reliable contractor to build your house. You wouldn't want to hire someone with a questionable track record, right?
Exactly. A vulnerable base image can compromise the security of your entire application, even if your code is perfectly secure. It's like building a fortress on a foundation of sand.
Makes sense. So trusted base images are a must. What other steps can we take to secure our container images?
Minimizing the attack surface is another important principle. This means reducing the number of unnecessary components and services running within your containers. The less you have running, the fewer potential points of attack there are.
Ah, the keep it simple approach. So no installing extra software packages or services just because they might be handy someday.
Precisely. It's all about following the principle of least privilege. Only grant your containers the permissions they absolutely need to function correctly. Don't give them any more access than they need.
Okay, I'm getting the picture. Limit access, minimize the attack surface, and start with a solid foundation by choosing trusted base images. Are there any other security best practices we should keep in mind?
Absolutely. Regularly scanning your container images for vulnerabilities is another essential practice. There are tools available that can analyze your images and identify any known security issues. Sort of like having a security guard patrolling your container images looking for any weaknesses.
That sounds like a good idea.
Yeah.
So if these tools find a vulnerability, what do we do about it?
The good news is that most vulnerabilities can be addressed by updating your base images, applying security patches, or even rebuilding your containers with a more secure configuration. The key is to be proactive and stay ahead of the game.
Got it. Regularly scan for vulnerabilities and address them promptly. Now, while security is paramount, we can't forget about performance. We want our EKS applications to run smoothly and efficiently. What are some best practices for ensuring optimal performance in EKS?
Great question. Achieving top-notch performance in EKS involves a combination of factors, and it starts with choosing the right instance types for your nodes. Amazon EC2 offers a wide variety of instance types, each optimized for different types of workloads. Some are great for compute-intensive tasks, others excel at handling large amounts of memory, and others are designed for high-performance networking.
So it's all about finding the right tool for the job, matching the instance type to the specific needs of my application.
Exactly. And don't forget those handy tools we discussed earlier. EKS Auto Mode and Managed Node Groups. They play a key role in optimizing performance by automatically scaling your cluster resources up or down based on demand.
Right. So if my application traffic suddenly spikes, EKS can automatically spin up more nodes to handle the load. And when things settle down, it can scale back down to save resources and cost.
Precisely. It's like having an intelligent traffic cop directing traffic flow based on real-time conditions, ensuring that everything moves smoothly and efficiently.
Okay, that makes sense. So we've got the right instance types and we're leveraging auto-scaling. What else can we do to squeeze every ounce of performance out of our EKS applications?
Well, performance optimization goes beyond just the infrastructure. You also need to think about how your applications themselves are designed and how they interact with other services.
You're saying that even if I have the best infrastructure in the world, my application code can still bottleneck performance.
Absolutely. If your application code is inefficient, or if it's constantly making slow network calls to other services, it's going to drag down performance no matter how powerful your infrastructure is.
Okay, that makes sense. So what are some tips for writing efficient application code for EKS?
One key principle is efficient resource utilization. Your application should be designed to make the most of the available CPU memory and storage resources without being wasteful. Avoid things like memory leaks, which can gradually consume more and more memory over time. And make sure your applications release resources when they're no longer needed.
So no hoarding resources. Make sure your applications are good citizens and share the resources fairly.
Exactly. Now let's talk about those network calls. The way your EKS applications communicate with other services, whether it's databases, message queues, external APIs, or other microservices, can have a huge impact on performance.
Okay, I'm imagining a scenario where my application is constantly making slow network calls to a database. Even if the database itself is fast, those network calls are going to introduce delays, right?
You got it. It's like having a super fast sports car stuck in rush hour traffic.
Definitely not the kind of performance we're after. So how do we avoid those communication bottlenecks?
One effective strategy is to minimize the number of network calls your application makes. Can you batch multiple requests together instead of making individual calls for each one?
So it's like combining multiple errands into one trip rather than making separate trips for each one.
Exactly. And if you're dealing with large amounts of data, consider using compression to reduce the size of the data being transmitted over the network. Smaller payloads mean faster transmission times.
Makes sense. Now, what about latency? I know that network latency can be a major performance killer, especially when dealing with geographically distributed services. Any tips for mitigating that?
Absolutely. Caching is a powerful technique for reducing latency. By storing frequently accessed data closer to your applications, you can avoid those expensive round trips to distant servers, resulting in much faster response times.
So it's like having a local grocery store right around the corner, instead of having to drive across town every time you need a gallon of milk.
That's a perfect analogy. And if you're dealing with services that are geographically dispersed, consider using a content delivery network or CDN to distribute your content closer to your users.
Yes, CDNs. Those networks of servers strategically located around the globe, ready to deliver content with lightning speed.
Precisely. By leveraging a CDN, you can ensure that your users get the fastest possible access to your content, no matter where they are in the world.
So we've covered a lot of ground when it comes to optimizing performance in EKS. Choose the right instance types, leverage auto-scaling, write efficient application code, minimize network calls, embrace caching, and leverage CDNs when appropriate. Sounds like a holistic approach is key.
You've got it. Performance optimization is an ongoing journey, not a destination. It requires continuous monitoring, analysis, and refinement to ensure your EKS applications are always running at their peak.
That makes sense. Now, I'm curious to learn more about some of those advanced features and integrations that you mentioned earlier. Let's dive into that world and see what other treasures we can uncover.
One of the things that makes Amazon EKS so compelling is its incredible extensibility. It's like having a platform that's built to evolve and adapt to your ever-changing needs.
Extensibility, huh?
Yeah.
So we're talking about a world of add-ons and integrations that can supercharge EKS and unlock all sorts of cool capabilities.
You got it. EKS has a thriving ecosystem of add-ons that can enhance its functionality in countless ways. It's like having a toolbox full of specialized tools that you can use to customize your EKS experience and tackle specific challenges.
Okay, I'm all ears. Give me some examples. What kind of add-ons are we talking about here?
Well, one of the most popular and widely used add-ons is the AWS Load Balancer Controller. It simplifies the management of load balancers for your EKS applications, making it incredibly easy to distribute traffic across multiple instances of your application and ensure high availability and responsiveness.
Load balancers. They're like the traffic cops of the internet, making sure that all those user requests get routed to the right servers. They're essential for building scalable and resilient applications, right?
Absolutely. And with the AWS Load Balancer Controller, you can manage those load balancers directly from within your Kubernetes environment.
Oh, wow.
Using familiar Kubernetes commands and configurations.
Okay.
It's all about streamlining your workflow and making it easier to manage your infrastructure as code.
So no more jumping back and forth between different consoles and tools.
Yeah.
I can handle everything right from within my Kubernetes deployments.
Exactly. It simplifies the process and makes it much easier to automate your load balancing configurations, freeing you up to focus on the things that matter most, your applications.
I love it when things are automated. It's all about working smarter, not harder, right?
Absolutely. And speaking of automation, have you heard of Carpenter?
Carpenter. That sounds intriguing. It's not a misspelling of carpenter, right?
That's right. Carpenter is an open source cluster autoscaler that was specifically designed for Kubernetes. It's like having a team of skilled carpenters constantly monitoring your EKS cluster and making adjustments as needed.
Okay, that sounds pretty cool. But how does it actually work? Does it build little wooden houses for my containers?
Not quite, but it's almost as magical. Carpenter intelligently provisions and deprovisions nodes in your EKS cluster based on the real-time demands of your applications. It's like having an automated system that expands and contracts your cluster to ensure that you have just the right amount of compute power at any given time.
So it's like having an elastic infrastructure that stretches and shrinks as needed.
Precisely. Carpenter constantly monitors the resource requirements of your workloads and adjusts the cluster capacity accordingly. This not only ensures that your applications have the resources they need to perform optimally, but also helps you optimize costs by avoiding over-provisioning resources.
Well, Carpenter sounds like a must-have tool for anyone who wants to optimize their EKS cluster for performance and cost efficiency.
It is. And it's a testament to the vibrant and innovative Kubernetes ecosystem. There are constantly new tools and technologies emerging that push the boundaries of what's possible.
That's what I love about this world. It's
Yeah.
always evolving, always pushing forward. But with all these amazing tools and features at our fingertips, it's easy to get lost in the technical details. It's important to remember that the ultimate goal is to build applications that deliver real value to our users.
Absolutely. Technology is just a tool. The real magic happens when we use these tools to create solutions that make a positive impact and solve real-world problems.
Well said. So as we wrap up our deep dive into Amazon EKS, what are the key takeaways for our listeners? What do we want them to remember?
First and foremost, EKS offers an incredibly powerful and flexible platform for deploying and managing containerized applications. It's built on the foundation of Kubernetes, which brings a wealth of features, a robust security model, and a vibrant ecosystem of add-ons and integrations.
And with features like EKS Auto Mode and Managed Node Groups, you can choose the level of control and automation that best suits your needs and expertise.
Right. And security should always be top of mind. Take advantage of features like IAM and EKS Pod Identity. And follow security best practices for building and deploying container images. Remember, a secure application is a happy application.
And let's not forget about performance. Choose the right instance types, embrace auto-scaling, write efficient application code, and leverage caching and CDNs to create smooth and responsive user experiences.
Most importantly, never stop learning and experimenting. The world of Kubernetes is constantly evolving, so stay curious and keep exploring new possibilities.
Excellent advice. So there you have it, a deep dive into the fascinating world of Amazon EKS. We hope you've enjoyed the journey and that you're feeling inspired to explore all that EKS has to offer.
Happy building.